Hi, Year 8. This week we are going to continue with our acids and alkalis topic, and we are going to talk a bit more about indicators. So I'd like you to turn in your booklets to page 9, and I'd like you to pop today's date at the top of page 9. Now we're actually going to make our own indicator this week. If we think back to the indicator that we've already talked about litmus indicator. And we've already seen that litmus changes colour to red in acid and blue in alkali. So we've already covered one. But we are actually going to make our own indicator this week from red cabbage. Now, red cabbage is not the only plant that could be used to make an indicator. Any strongly coloured plant, perhaps maybe beetroot is a good example, could be used to make an indicator, because what we're going to do is we're going to extract the dye, and the dye will change colour depending on whether it's in an acid or an alkali. Now our first blank on page 9, and if we think about the indicator we've already covered, we can say that an indicator changes colour if a substance is acidic or alkaline. Now we're going to chat a bit to make this indicator from red cabbage. So we would take the red cabbage and we would chop it up. Then we would pop our chopped red cabbage into a mortar, and we would use a pestle to grind up the red cabbage. And it would be really important to grind it up well to release all the dye. Then we would use a measuring cylinder and we would pour 10 cubic centimetres of meth or methanol into the chopped cabbage. Now the purple dye will dissolve in the methanol. Step 2 then, we would use a pipette to suck up this purple dye. We would pop it into a beaker, and this would be the indicator that we can use to test our samples. Now you have a space for a diagram on page 9 as well, so I'd like you to pause the video and you can copy this diagram in and label each of the apparatus. Now if we think then about what we would do with this indicator. Again, you've got a results table on page 9, and you can see that we have 6 samples, some acidic, some alkaline, but we are going to test them with this red cabbage. Now, if we were in school, you would do all this, but Mrs. Cummings has done the next best thing, and she has recorded a little demonstration for you to watch. Now, as you watch the demonstration, I'd like you to make sure that you're filling in the first column. So fill in the colour that the solution turns to. Now, after the demonstration is done, we'll come back to the results table and we'll chat a bit more about the last 2 columns.
Year 8, ask Natalie how to make it your own indicator. In this mortar I have some red cabbage, and to it I'm going to add 50 mils of methylated spirits. And with a pestle I'm going to crush the cabbage so I can get all the red dye out of the cabbage. And as they say in Blue Peter, I have did some earlier. So I have 6 test tubes with lemon, ammonia, sodium hydroxide, hydrochloric acid, vinegar and lime water. And to each of these substances I'm going to add a red cabbage indicator. So into lemon, it has turned it a pinky red colour. With ammonia, the indicator has turned the ammonia a greeny blue. Into sodium hydroxide, we have a dark green. Into hydrochloric acid, has turned the acid red. In vinegar, the homemade indicator has turned the vinegar a pinky red. And finally our lime water, our homemade indicator, has turned a greeny blue colour.
Now folks, we should have each of the colours in for each of the samples. Now we've got to decide which sample is acidic and which is alkaline, and we've got to work out this indicator's colour change. Now, like I've already said, we know litmus, but each indicator will have its own colour change. So the first thing I'd like to do is to pick a sample that is definitely acidic. So let's pick lemon. And we know that lemon turned a red-pink colour. And I know that lemon is definitely acidic, so I can conclude that the colour of red cabbage indicator in acid is red-pink. Now I've got to do the same for an alkaline sample. Now the best known alkali is sodium hydroxide, and we saw in the demonstration that it turned green. So again I can conclude that the colour of red cabbage indicator in alkali is green. Now I can go through my samples then and I can decide according to this colour change whether they are acidic or alkaline. So our lemon is definitely an acid, ammonia is an alkali, sodium hydroxide is an alkali, hydrochloric acid is an acid, as is vinegar, and lime water is an alkali. Now think back to your litmus last week, pause the video, fill in the colour these samples would have turned with litmus, come back and check that you've done it correctly. Now, moving on, year 8, we have got another to discuss. Now, our next indicator is a universal indicator, and it is actually a mixture of different indicators. And it's a particularly useful indicator because it changes not just into two colours, but it will change into a whole range of colours depending on the strength of the acid or the alkali. Now we've already completed page 10 in our books, so we're now on to page 11, and again pop the date at the top of the page and we're going to fill in the first couple of lines. So it is more useful than litmus indicator because it will produce a range of colours to show how strong the acid or the alkali is. Now we're going to talk about these colours, and I want you to notice first of all that each colour is associated with a number, and these numbers are the pH numbers, and this is why this diagram is called the pH scale. So when I add the universal indicator into a sample, it will change to whatever colour, but then we can also measure the pH number of the sample. Now if we were to start in the middle, you can see that in the middle we have got pH number 7. So a solution with a pH number of 7, when universal indicator is added to it, will turn green. Now an example of a solution like this would be water, and water is neither acidic nor alkaline, and we can say that water is a neutral solution. Now if we look at the pH numbers that are less than 7, we've got pH 1 to 6. Now if we look at, first of all, at pH numbers 1 to 3, now you can see that they're matched up to various shades of red. Now these samples would all be strong acids. So if I were to add universal indicator into a sample of stomach acid, it would turn a dark red colour, and I would match the colour up as best I can to the shade of red that it is, and I could assign this stomach acid a pH number. So pH is 1, 2, 3, all red colours are all strong acids. Now as the pH number gets higher, the acid actually gets weaker. So I can see that pH 4, 5, 6 are matched up with orangey, yellowy colours. So samples that universal indicator would be added to that change into this colour would be weak acids. And this would be like lemon juice or orange juice or vinegar. So pH 1 is the absolute strongest acid, getting progressively weaker until pH 6. So any number below pH 7 is an acidic sample. Now, when we get greater than 7, we are at the alkaline end of the pH scale. Now, when we add universal indicator in and it changes to a bluey colour, we have got a weakly alkaline solution. Now, this would be for samples like soap or baking powder. And again, each shade of blue is associated with a pH number. So pH 8, 9, 10 are all weakly alkaline solutions, but they're getting a little bit stronger from 8 to 10. Now, the last lot of pH numbers right up at the end then are for our strong alkalis. So pH 11, 12, 13, 14, getting progressively more purple, are all strong alkalis, and oven cleaner is an example of a strong alkali. So pH 14 is the strongest possible alkali. Now, we can say then that any pH number greater than 7 will correspond to an alkaline solution, getting stronger from pH 8 right up to pH 14. So you can see that universal indicator is a really useful indicator because it gives us this measure of strength. Now, you need to pause the video and you need to, as best you can, and I know that it's difficult to get the different shades of red and purple, but as best you can, colour in the pH scale to match what you see on the screen. Now, if we were in school, we would use this universal indicator and we would use it to determine the pH numbers of a range of samples. Now again, Mrs. Cummings has done this, but let's just take a look at the results table first. Now you can see on page 12 that you've got this results table. There's a column for the substance that Mrs. Cummings will call out. There's a column for the colour, again Mrs. Cummings will call out. And then you'll notice that she will hold the test tube up against the pH scale, and this is where you need to, as best you can, match the colour to a pH number. And it's not an exact science, but we're matching it as best we can to a pH number. Then once this is all done, we can use our knowledge to decide whether the solution is acidic, alkaline or neutral. Now remember, you can pause the video as Mrs. Cummings works through it so that you can get all the colour changes and all the substance names and all the pH numbers filled in as she goes along.
Testing the pH of different solutions using universal indicator. Our first one is washing powder. We have a deep purple colour. Lemonade is our next one. We have an orangey red. Vitamin C. Is an orangey red. The fourth one is our skull soap. An orangey red. Vinegar. It's red. Oven cleaner. Purple. Bubble bath. Is orange. Toothpaste. Green. Water. Green. Window cleaner. Red. Hand sanitizer. is an orangey red. And finally, bleach. Like a dark blue.
Now you rate if we just check that we have filled in our results table correctly. And I'm only going to talk about the first sample. Now the first sample that Mrs. Cummings tested was washing powder. So you should have filled in the substance name in the first column. Washing powder turned universal indicator a purple colour. And when we held that up to the pH chart, we could see that that would correspond to a pH 13 or 14. And like I said, it's very difficult to match it exactly. Now the last column is where you need to use your knowledge to fill it in. Now if we think back to the pH scale, we said that any pH above 7 was an alkaline. When we reached pH 11, we had reached the strong alkalis. So I can say that washing powder then is a strong alkali. Now it's important that you've done this for each of the samples that Mrs. Cummings tested, so you might need to go back and replay the video, but make sure that you fill in your results table and you work out whether it's an acid, alkaline or neutral sample for each one of the samples.